Hello everybody. In today's video we want to look at oxidizing and reducing agents. So I'm still using this example, the reaction between copper 2 oxide and hydrogen, to give us copper and water. Of course we can see that copper 2 oxide loses oxygen to become copper, and that is reduction, and hydrogen gains oxygen to become water, and that is oxidation. Now, remember we said oxidation and reduction occur simultaneously. So, it means there is no reduction without oxidation, and there is no oxidation without a corresponding reduction. So, we can bring it together and say if a substance in the chemical reaction oxidizes, the other substance causes the oxidation to occur. So for example, in this reaction, hydrogen is oxidized. So that oxidation of hydrogen is caused by copper 2 oxide. So because of that, we will call copper 2 oxide the agent of oxidation on hydrogen, and in the short form we call it an oxidizing agent. So we can name hydrogen the same way we name copper 2 oxide. So we can see that copper 2 oxide is reduced in this reaction. So it is the hydrogen that causes copper 2 oxide to be reduced. So because hydrogen is the cause of reduction of copper 2 oxide, hydrogen is the reducing agent. So this reaction below illustrates everything for us. So this is reactant A, which is an oxidizing agent. It is reduced by reactant B, which is a reducing agent. And reactant B itself is oxidized by reactant A, which is an oxidizing agent. So we can define an oxidizing agent as substance that oxidized the reducing agent and got reduced by the reducing agent. And in the case of reducing agent, a reducing agent reduced the oxidizing agent and got oxidized by the oxidizing agent. The two common oxidizing and reducing agents in the lab are potassium manganate 7, which is a powerful oxidizing agent, and potassium iodide, which is a very good reducing agent. We have some others, but they are not covered or they are not needed by your syllabus. KMnO4 is the chemical formula for potassium manganate 7, but often you will see it written as MnO4 minus. They have removed this potassium ion from the compound. Remember, it's like this: K plus and MnO4 minus. So when you remove K plus, so you have MnO4 minus. So you can see it written as KMnO4, or you see it written as MnO4 minus. When potassium manganate 7 is acidified, that is, when it is in the presence of a little acid, it is a powerful oxidizing agent in the laboratory. So it can undergo reaction or redox reaction with any type of reducing agent. So you will often see the reaction as written this way in your examination. Remember, manganese is a transition element, and one of the properties of transition elements is that they can have more than one oxidation state. So in manganese, in potassium manganate 7, the oxidation state of manganese is 7. So that is why we call this manganate 7 ion. So when it gets reduced by a reducing agent, it becomes manganese 2, Mn2 plus. So the oxidation state of manganese is 2 here and it is 7 here. Remember, an oxidation agent can only react with a reducing agent. So if you want to test for a reducing agent, you can use an oxidizing agent. So if the reaction between your oxidizing agent and the substance that you are reacting it with, it means that substance is a reducing agent. So we can use acidified potassium manganese 7 to test for a reducing agent in the laboratory. Acidified potassium manganese 7 solution is purple, and when you react it with a reducing agent, it gets reduced to manganese 2 ion, and manganese 2 ion is colorless. So when you see color change from purple to colorless, it means the substance that you react your potassium manganese 7 with is a reducing agent. So that is how to use acidified potassium manganese 7 to test for a reducing agent. The same way we use potassium manganese 7 to test for a reducing agent, we can also use potassium iodide, which is a powerful reducing agent, to test for an oxidizing agent. You can see our potassium iodide reacting with hydrogen peroxide. Remember, I said an oxidizing agent will always react with a reducing agent. So this is our reducing agent, and therefore our hydrogen peroxide is an oxidizing agent. So this is the medium of the reaction. The way we have acidified potassium manganese 7, sulfuric acid here is just to provide acidic medium for this reaction. So this is our reducing agent, this is our oxidizing agent. So if you look at the other side of the equation here, we will see that our reducing agent has reduced hydrogen peroxide from H2O2 to become H2O, which is water. So telling you that potassium iodide is a powerful reducing agent, and it can also be used in the lab to test for an oxidizing agent. This long equation up here, you don't really need it for your examination. The equation that you need is what I'm writing down here, where you have the iodide, iodide ion here from the potassium iodide. Iodide ion is going to be I minus, so which is aqueous, and then it undergoes oxidation to become iodine solution. So in order to monitor this reaction, you have to look at the color change, like the way we have it when we are talking about potassium manganese 7. So potassium iodide is colorless, and iodine is red brown. So when you see color change from colorless to red brown, it means your potassium iodide has been oxidized. So it means what you react your potassium iodide with is an oxidizing agent. So that is a test for oxidizing agent. So before we go, let's look at this question. The question says, identify the oxidizing and reducing agents in these reactions. So we have iron reacting with chlorine to give us iron 3 chloride. So if you check, the easiest way to solve this problem is to use the oxidation number. So iron is an element in an uncombined form, so its oxidation number is going to be 0. Your chlorine is a molecule that has not combined with anything. It's going to have 0 as its oxidation number as well. But here we have a compound that is made up of iron and chlorine. So iron in this compound is iron 3, so it means the oxidation number of iron is plus 3, and that of chlorine is going to be minus 1. So of course you can see that the oxidation number of iron increases from 0 to plus 3. Whenever there is increase in oxidation number, that process is oxidation, and the substance that will undergo oxidation in the chemical reaction is a reducing agent. So our iron is the reducing agent. Of course, if iron is the reducing agent, automatically chlorine is going to be our oxidizing agent. You can also look at the oxidation state of chlorine as well. So it reduces from 0 to minus 1. So it is so that is a reduction process. So telling you that chlorine is an oxidizing agent. If you look at the second example here, it is 0 as well. and this is going to be 0, and copper ion in this compound is copper 2. This is copper 2 sulfate, so the oxidation state of copper is +2. And if we check the iron here, this is iron 2 sulfate. The oxidation state of iron in this is also +2. So the way we have it over there, from 0 to +2, that is increase in the oxidation state, and that is oxidation. And iron 2 is going to be the reducing agent because it undergoes oxidation. So definitely copper 2 ion is our oxidizing agent. So we write OA on top of this. So for the last question, it is also very easy. We just look at the movement of oxygen. So here we have carbon monoxide, carbon with only one oxygen atom, but here it becomes carbon dioxide. So it means carbon monoxide has gained oxygen. Gaining of oxygen is oxidation. So if you undergo oxidation, it means you are a reducing agent. So if you can identify the reducing agent, definitely the other guy is going to be the oxidizing agent. You can also check as well. Iron here is iron 2, but here the oxidation state of iron in this side is 0. So from +2 to 0, that is reduction, and only an oxidizing agent will undergo reduction in the chemical reaction. So with this, we get to the end of this class. In fact, that is the end of this redox reaction series. I've made a one-page redox summary sheet with all of this that we discussed in this series. So I have it in the description link below, so you can check it out. It is completely free. Thank you so much, and see you in the next series.